So what we've done so far is we've done exponential graphs, correct? Then we did solving exponential by common base. So we'll be reviewing that all this week on daily quizzes. Then we did your word problems. We did word problems. Our word problems that we did were half-life doubling and tripling. We did compound interest questions. And we did ones where it was just increasing or appreciating or decreasing or depreciating. So we had to add it to one or we subtracted it from one. Those were our word problems. Then we looked at log graphs. We looked at log graphs and all the parts of log graphs. Then we did conversions from exponential to logs, logs to exponential, and we learned how to do change of base. So that's where we did this division here so that we could actually type into our calculator and get an answer. Okay? So today what we're going to go over is we're going to go over how could we maybe do solve a log without even typing into our calculator. It doesn't always work, but sometimes does. And to solve exponential and logs without our calculator. Okay? So if I give you this, so this is change of base. So say I gave you log 10 and log 2 like this. So I've done it the other way. If I give you an example like this, and I tell you to express it as one logarithm, how could we write this? So it's right now it's 2 logs. I want it to be expressed as 1 log. Yeah. Yeah. So this 2 would just be the base. So you could write this as log base 2 of 10. You guys told me if it was log base 2 of 10, you could just go like this. Could you not? We agree? So we always remember that we can go this direction, but what we have to remember is that we can also go that direction too. Make sense? So you have to remember that you can put it back together, not just separate it. Okay? Now where would that be helpful? If I gave you log 9 divided by log 3. And I asked you to solve it. And I took away your calculator. So you can't go log 9 divided by log 3 because you don't have your calculator.
Would it be multiple choice?
We're just talking about theoretically right now. This is how it goes. So what could I turn that into based on what we just went over? Log base 3 of 9. Do we agree? Okay. Now, up until now, we've just punched into our calculator and got an answer. But these ones, a lot of the time, you can look at them and figure out what they are without your calculator. So what your calculator is doing indirectly is this. It's saying 3 to what exponent is this? 3 to what exponent is 9? 2. Log base 3 of 9 is 2. There's my answer. That's all your calculator is doing. It's figuring out what exponent I have to raise this base to get me that. So 3 to the power of what is 9? That's what it's asking you to do. That's all it's asking you to do. So in this case, 2 to the power of what is 10? I have no idea. It's a decimal, right? So probably not going to ask you to do that in your head. Okay? But when it's one like this, 3 to the power of what is 9? It's 2. There's your answer. Okay? So if you're getting some crazy answers like 500, 2 to 500 is 10, probably wrong. Okay? So you can actually reason through them as well. So let's look at this. What would this answer be? Log base 5 of 125. 5 to what exponent is 125? 3. So our answer would just be 3. So these ones people can punch in a calculator and they're like, yeah, okay, we'll learn this method, but we're just going to type in our calculator anyways, Lepp. What if I give you this? So remember, if I ever give you something with a variable, they're going to have to tell you what the variable stands for. So like b is greater than 0, let's say. Okay? And it can't equal 1. So you could plug it in and try and figure it out that way, right? You could go like log 1 divided by log 2, log 1 divided by log 3, log 1 divided by log 4, and see if you can get a trend and figure out what it is that way. Or you can say to yourself, using the math that I just said, b to what power is 1? 0. It's a b. Huh? I'm not asking you what b is. I'm asking you what log base b of 1 is. So b to what power is 1? 0. So it's 0. So log base b to the 1 is 0. So anything to the power of 0 is 1, correct? So if I write anything, I could write log smiley face of 1, and my answer is still 0. Because anything to the power of 0 is 1. What if I give you this? Smiley face. Okay, what if I give you this? Log 4 to the 4 to the k. So the 4 is a base. Okay, what I'm going to tell you right now is the very first thing I would do is you can take this exponent, it's called power rule, which we're going to discuss tomorrow too. You can take this exponent and you can drop it in front. Only if it's a log though. You have to have a log here, and then you can take this exponent, you can drop it in front. Okay, it's called the power rule of logs. So any exponent can drop in front. Ahem. Oh, there we are. Yeah. All right. So, yeah. After you move it to the front, we're going to deal with it in a second. Okay, so we have k log 4 to the 4. That's what's left over now, right? K log base 4 of 4. What is log base 4 of 4? 1. Because you can say 4 to what power is 4? 1. Or you could do this. And what's log 4 divided by log 4? 1. So either way, it's going to be k times 1. So it's just k. So if ever you have like log a to the 10, my answer is 10. Or log 3 to the 3 to the k, my answer is k. So whenever you have a to the something, your answer is that something. Or 3 to the 3 to that something, the answer is that something. Because you can take this something and put it in front. If I have log a to the 10, I can take this 10 and I can drop it in front. And now it's 10 times log a to the a. And what's log a to the a? 1. So it'd be 10 times 1, which is 1. Or 10, not 1. That makes no sense. Okay? So I'm going to give you about 5 minutes to do about 4 questions in your textbook, and then we're moving on. So the last thing I want to go over is solving. So if I say solve, and I say algebraically, and you show no work, you get no marks. Because that means you went y1, y2 in your calculator. And that's not algebraically, that's graphically. And I'm testing you on a curriculum outcome that is algebraically, not graphically. So If I say algebraically, you have to do it correctly. So if I gave you this, 2 to the x equals, example 1, 4 to the x plus 2. We cannot change this to logarithmic. The only way we can turn it to logarithmic is if there's only one variable in the exponent, right? I have 2. So if I say algebraically, what's the only way you can do this one? Common base. Common base. That's the only way you can do this. If I give you 2 exponents and I ask algebraically, I have to be able to let you do it by common base. That's it. That's the only way I can ask it to you. Okay? If I give you 2 exponents and you can't do common base, I cannot ask that algebraically. I have to ask it graphically. Okay? So if I gave you 2 to the x plus 3 equals 3 to the x plus 4, I would have to ask that graphically. I cannot ask it algebraically. You are not forced to do that algebraically. It is not in your curriculum. Okay? So if I give you 2 exponents and I say algebraically, you have to be able to do common base. Have to. So I can make them both be base 2. So this is from before. 4 is 2 to the 2. X plus 2. And we have to remember to distribute it. So we get 2 to the x equals 2 to the 2x plus 4. And we'd solve it. X equals 2x plus 4. Subtract 2x. Negative x equals 4. I don't want negative x. I want positive x. So I have to divide by negative 1. So x equals negative 4. And I would have my solution. Okay? So if I ask you to solve algebraically with 2 exponents, I have to give you common base. I have to allow you to do common base. Okay? 3-1, that was not the case. For your class, I have to. If I went and this was a base 2 and this was a base 3, I would have to ask you graphically. Does that make sense? Okay. So I can ask you to do it algebraically, though, in giving you this. 2 to the x plus 3 equals 3. Now, some of you may say, but you just said you can't. You just said that you have to do graphically. I said I have to ask you graphically if there's an exponent on both of these. Is there? No. If I have one exponent, you can solve these algebraically. You convert it to a log. That is how you do it. So you either can do common base or you convert to a log if I say algebraically. So the moment that we can't do common base, I convert to a log. How do I convert to a log? Go to my formula sheet, pull the letters off my formula sheet, and do it. Okay? So this is A. This is Y, X. I'll read what the letters are. X. And this one's Y. So we fill it into our formula. Our formula is X equals log base A of Y. So X is X plus 3 equals log base 2 of 3. And I want X by itself. So now what do? Subtract the 3. When I subtract the 3, I'm going to do this because you're going to do this wrong if you don't. X equals log base 2 of 3 is a thing all to itself, correct? That's a log all to itself, is it not? And then behind that, I'm going to subtract 3. So what am I going to do? I'm going to get the answer to this, hit enter, and then subtract 3. Do not make this 3 and this 3 join and put a 0 and say it errors and I can't find it. Okay? Now, could I go y1, y2 and get the answer right off the bat? Absolutely. There's nothing wrong with that. Do that. But you're going to have to show the algebraic method and then see if they match, right? If you do this one, find the algebraic method, give me a decimal, and then go y1, y2 and get a decimal, you can check them to make sure you're correct, which would be your best bet, because then you'll catch your errors. So if I do this one into my calculator, I'm going to get, if I have my log base button, life is way easier. Log base 2 of 3 minus 3. And I get x equals negative 1.42. So all I did was convert it to a log. We agree? So, example 3, example 4, and example 5 are for homework. Okay, you guys do those. I want you to solve them algebraically. The title's up here, solve algebraically for all these examples. So write those ones down. Yes. Yep. That work? So solve these algebraically. We're going to go through